nitrogen. Before you can actually give or illustrate or draw the Lewis structure, the correct Lewis structure of the molecule, you have to identify first your total valence electrons, right? What would be the total valence electrons in nitrogen trifluoride? Can you do? Ano yung TVE class ng nitrogen trifluoride? Nitrogen has 5 valence electrons while fluorine has 7. How much would be your TVE? 21 plus 5, right? 26. O divided by 2.
13 po.
13. Then you now draw your proposed Lewis structure. The 3 fluorine would be the terminal atoms, and you will get how many bonds? How many bonding pairs? You will get 3, right? So from the TVE, which is 21 plus 5, 20, divided by 2 is 13. You subtract from 13 the number of bonds that you have created. So that is minus how many? 13 minus?
6 po.
6. Bonds lang, bonds.
Ay, 3 po.
3. So ilan ang natira? 10, right? 10 pairs, 10 bonding pairs. 3. But if you're going to look at the 10 remaining bond pairs, you're going to distribute those 10 among your terminal atoms fluorine. So each of the fluorine atoms in the terminal atoms will get 3 lone pairs each, right? 3 lone pairs each. And the 10th non-bonding pair will be moved and given to your nitrogen. So your nitrogen, correct?
Yes, sir.
The 10th non-bonding pair would be for nitrogen, correct? Okay. So how many electron domains do you have for nitrogen? How many electron domains do you have for nitrogen? Ilan? How many, class?
4 po.
You get 4. Very good. 4 electron domains. What are these electron domains? What are these 4 electron domains? 3 are bonding pairs, while 1 is a non-bonding pair, right? So there are 4. Therefore, if there are 4 electron domains, the electron domain geometry for the molecule is tetrahedral, right? Tetrahedral. But then you get 1 lone pair that rests on nitrogen. Therefore, you will say the molecular geometry is trigonal pyramidal. How do you represent in your molecular shape designation your trigonal pyramidal molecular geometry? It would be AX3E1, right? A is a central atom. You may represent that as nitrogen. X would be the number of bonding pairs. That is 3. There are 3 bonding pairs. And you have a lone pair, a non-bonding pair. So E1, NX3E1 or AX3E1 would be the molecular shape designation for the molecule. Do you understand, class? Nakuha nyo?
Yes po, sir.
Okay, very good. Now, what about the next? There are your non-bonding electrons for fluorine and nitrogen after doing the Lewis structure. What about for the ion, the carbonate ion? What would be the TVE class for carbonates? For your carbonate ion? TVE would be equal to,
Sir, yung TDE po is equals to 4 minus 18 minus 2 po.
total. 4 for carbon times 6 times 3 for oxygen, which is 6. So 4 times 6 times 3 is 18 plus 4 is 22 plus 2, right? Because you have a negative charge. Tama?
Yes po, sir.
6 plus 18 plus 2. How much? How much, class?
Sir, 24 po.
6 plus 18 plus 2. Ilan?
Sir, yung TDE po nitong carbonate
Carbon is
ion
4. 4.
is 24 po.
26 po.
Sandali ha.
26 po.
3 times 6 is how much?
18 po.
18 plus 4.
22 po.
22 plus 2 is how much?
24 po.
24. Okay. So you have 24 total valence electrons divided by 2. Divided by 2, right? So you get 12. Now assemble your proposed Lewis structure. You have 3 oxygen around carbon, so you will get to use how many bonds? 3 bonds, right? Ilan yung TVE natin? Ilan yung TVE natin, class? Na compute natin?
24 po.
24 po.
Divided by 2, right? Divided by 2. So 12.
12.
12 minus 3 is how much?
9 po.
9. Okay. 9. 9 non-bonding pairs. You're going to distribute the 9 bonding pairs to your central atom oxygen. So each of the oxygen will get how many electrons, how many non-bonding pairs? Ilang non-bonding?
3 po, sir.
3. 3 of the 3 oxygen, terminal oxygen atoms will get 3 non-bonding pairs each. Right? 3 non-bonding pairs. But then your carbon will not be stable. Right? Because carbon only has how many electrons around it? Ilang electrons around carbon atom? There will only be 6, right? So mag-delocalize tayo dito from lone pair of any of your terminal atoms oxygen. But still that will count as 1 electron domain. So how many electron domains do you have for the central atom carbon? How many all in all?
3
How
po.
many? There would be 3 electron domains all there in the bond. So bonding electrons lahat, right? So if there are 3 electron domains, the electron domain geometry is trigonal planar. Trigonal planar, right? But if you don't have any lone pair on carbon, the central atom, therefore, the molecular geometry will also be trigonal planar. Nakuha? So what would be the molecular shape designation for this? A, X, X what? AX
3 po.
3 po.
3. Okay, X3. You don't have a value for E because you don't have non-bonding electrons, right? You don't have non-bonding pairs. Okay? So that is how to do the molecular shape designation. What about this? Identify the hybridization and geometry around the identified atom. Your carbon, double bond carbon. What is the hybrid of a double bonded carbon? sp3, sp2, or sp? Ano class? sp2 carbon. Double bond carbon is sp2, right? Tama?
Yes po.
Okay, what would be the geometry of that double bonded carbon? This one is a double bonded carbon. Ito,
Trigonal planar po.
trigonal planar. Very good, Iha. You are? Your name?
Christian po.
Christian. Very good. What about the carbonyl? Carbonyl group C, double bond O. What is the hybrid of this carbon? sp, sp2, or sp3? Double bonded carbon is
SP2.
sp2. What is the shape?
Trigonal po. So,
Trigonal planar. Yes, trigonal planar. The hydroxyl group, ito, OH. What is the hybrid of your oxygen? What is the hybrid of the oxygen? sp, sp3, sp2.
SP2.
sp3, correct. sp3. What would be the geometry of this molecule?
Tetrahedral po.
Now, because oxygen has lone pairs, right? It has bonding pair, non-bonding pairs.
Ben po ba?
Bend. Very good. It's bend because oxygen here has two non-bonding pairs. Needless to say, that's your hydroxyl group. Next, molecular cysteine. Cysteine molecule is an amino acid, one of the 22 most common amino acids. There are now 20 added now is the newly discovered natural amino acid, which is your selenocysteine. Before it was only 21. Wala pa yung selenocysteine. But now selenocysteine has been identified and included as one of your natural amino acids. You call this your proteinogenic amino acids. These are the amino acids that are used to form proteins. Okay. C single bond C. What is the hybrid of a single bond carbon?
SP3.
sp3. Very good here. What would now be the shape or geometry? Ayan.
Tetrahedral po.
Tetrahedral. Very good. Ang galing talaga ng MT1. What about this? Nitrogen bonded with a hydrogen. Nasaan yun? Ito. NH. What is the hybrid of nitrogen?
SP2 po ba?
SP3.
sp3. Nitrogen has one non-bonding pair. Pagka nitrogen is bonded to 3 atoms using single bond, ang hybrid nitrogen, you must remember na andun sa transparency, is sp3. What now be the hybrid of your nitrogen here?
Tetrahedral po.
No. I mentioned there is,
Trigonal pyramidal.
may lone pair siya. May
So,
lone pair
bento?
si nitrogen. Ano?
Ben po.
Hindi.
Sir. Trigonal pyramidal po.
Trigonal pyramidal. Very good. Okay, your nitrogen has, if a nitrogen has one non-bonding pair, its geometry or shape is trigonal pyramidal. Okay, bent is only for sulfur and oxygen as well. Okay, what about the C double bond O? This one, the carbonyl group.
SP2.
sp2. sp2, what is the geometry of this carbon?
Trigonal
this
planar.
Trigonal planar, of this molecule I mean. It would be trigonal planar. Okay, question class for sustain. Question for sustain.
None po.
Okay, very good. Now moving to the third molecule, this is your adenine, one of the nitrogen-containing bases in your nucleic acid. Okay, your nucleic acid, of course, includes your ribonucleic acid and your deoxyribonucleic acid, your GNA. And adenine is one of the 5 nitrogen-containing bases that are incorporated in this nucleic acid. Okay, this is your adenine. Adenine is a bicyclic structure. It contains a pentacyclic structure and a hexacyclic structure. Okay, it's a bicyclic structure. Okay, first, this triple bond class, C triple bond nitrogen. What would be the hybrid?
SP.
SP, right? It would be SP, correct? What would be now the shape or geometry of this molecule that contains this C triple bond N?
Diagonal po.
Diagonal, very good. It would be diagonal. It would be diagonal. What about the C double bond C? C double bond C, where is your C double bond C? There is your C double bond C. C double bond C. What is the shape or geometry? First, before I identify the geometry, what would be your hybrid for the carbon? Because from the hybrid of the carbon, you'll be able to identify its geometry. Anong hybrid ng carbon dito?
SP3 po.
sp,
3.
double bonded carbon.
SP2 po, sir.
Again,
SP2 po.
sp2. Very good. It's sp2 hybrid. What would now be the shape?
Trigonal po.
Trigonal what?
Planar. Planar.
Trigonal planar. Very good. Very good. You're doing very right. Oh, what about nitrogen single bond?
SP3.
sp3. Very good. What would be the geometry of this single bonded nitrogen?
Trigonal pyramidal po.
Trigonal pyramidal. Trigonal pyramidal. And with C. And with C. This is, anong shape nito, class?
Tetrahedral po.
And with C, ha? Anong shape? Single bond yan. Nitrogen single bond carbon. Ano sinabi nyo kanina?
Diagonal po.
Trigonal, pyramidal. Okay? Trigonal is single-banded lang si nitrogen. May lone pair si nitrogen. What about dito? Nitrogen double band carbon. What is the geometry of your, what is the hybrid of your nitrogen?
SP2.
sp2. sp2. What would now be the shape or geometry of your nitrogen?
Trigonal planar.
Again,
Trigonal planar po.
trigonal planar would be the shape or geometry. If it's single-banded, it's trigonal pyramidal. Okay? Trigonal pyramidal. Any question, class?
Na naman po, sir.
Okay. Look at this. These are the 5 different EDGs or electron domain geometries, right? The molecular shape designation, AX2, meaning there are 2 surrounding atoms. There are 2 surrounding atoms to your central atom. The central atom has 2 surrounding atoms represented by X2. You don't have any non-bonding pairs, right? Only pairs, only bonding pairs, because this is electron domain geometry. Of course, the shape would be classified as diagonal or linear, right? AX2. Molecules that exhibit such a molecular shape would be your beryllium chloride, hydrocyanic acid, and of course your carbon dioxide. Okay? All these exhibit diagonal or linear electron domain geometry. They kept this as their molecular shape designation. AX3, there are 3 atoms surrounding your central atom, 3 atoms surrounding your central atom, right? The shape is trigonal planar. 3 atoms surrounding your central atom. Example, the molecules that exhibit such shape class would be your boron trichloride, your sulfite ion, and your nitrate ion. Okay? Please be sensitive with these different molecules that exhibit such different electron domain geometry. Now, AX4, meaning there are 4 atoms. The molecular shape designation AX4, there are 4 atoms surrounding your central atom. These are the molecules. I'm sorry, class, this must be ammonium, may plus positive 1 charge. This your methane and your ammonium ion. Okay, the shape is, of course, tetrahedral. The shape is tetrahedral. The 4th electron domain geometry is your molecular shape designation AX5. There are 5 terminal atoms. There are 5 atoms surrounding your central atom. Okay? Kaya, you get this as the shape is your trigonal bipyramidal. Trigonal bipyramidal. These are examples of molecule class that exhibit such electron domain geometry. Egg 6, number 5, electron domain geometry. The shape is octahedral, and the molecules that exhibit such electron domain geometry are sulfur hexafluoride, and phosphorus hexafluoride. Sulfur selenium hexafluoride 2 exhibit such octahedral shape or geometry of your electron domain geometry AX6 molecular shape designation. These are the next. If these are electron domain geometry, this transparency class, or we call this slide, showcases the different molecular geometries. Molecular shape designation AX2E1 is angular or bent. There are two atoms surrounding your central atom. Two atoms surrounding your central atom, and you have one non-bonding pair that rests, of course, on your central atom. The shape is angular or bent. Example of molecules that exhibit such a molecular geometry is your tin chloride or your stannous chloride, sulfur dioxide, and your nitrogen dioxide. These are the molecules that are classified to show a shape that is identified as angular or bent shape. The other molecular geometry, this is the molecular shape designation AX3E1, meaning there are three atoms surrounding your central atom, and you have one non-bonding pair that rests on your central atom. The shape is trigonal pyramidal. Trigonal pyramidal, and this is of course exhibited by your molecule ammonia, NH3, and your phosphorus trichloride. Phosphorus trichloride. Okay? Those are the molecules that exhibit this shape, your trigonal pyramidal shape. The next molecular shape designation is AX2E2, meaning there are two atoms surrounding your central atom, and there are two non-bonding pairs that rest on your central atom. Okay, this is now your V-shape or bent molecular geometry. This is different from the angular or bent molecular geometry. Ang bent or angular, so mas maganda natin tawagin na lang angular. Isa lang yung non-bonding pair. You only have one non-bonding pair, but you have two bonding pairs. For bent or V-shape, bent pa rin, pero more particularly named as V-shape, there are two non-bonding pairs now that rest on, of course, to your central atom. Molecules that exhibit such shape class are your water molecule and your chloride ion. Chloride anion are the two molecules that exhibit V-shape or bent shape molecular geometry. Okay? The molecular shape designation AX4E1, meaning there are four atom pair is resting on your central atom. Okay? May I ask you, class, ilang electron domains meron dito? How many electron domains do I have in this molecular shape designation? How many electron domains do I have?
4 po. 4 po.
How many electron domains?
5.
There are 5, right? 4 are bonding pairs and 1 is a non-bonding pair. So there are 5 electron domains there in this particular molecular shape designation. What about here, class? How many electron domains do I have here?
4 po. 4.
4. 4. Dito. There's my pointer. Dito. How many?
4 din po. 4 ulit po. 4 din po.
4 din. Dito.
3.
3. 3 po. 3. 3 po.
3 electron domains here. So what would be the electron domain geometry of the molecule if there are 5 electron domains? What is the electron domain geometry?
Trigonal bipyramidal.
Very good, Iha. Trigonal bipyramidal. Your name is?
Kirsty po.
Kirsty. Very good. Very good. Now, the shape is, if one of the 5 electron domains is a lone pair, the molecular geometry now is identified as irregular, tetrahedral, or seesaw. It is necessary, class, that the electron domain that has non-bonding pair should be located on your equatorial position. On your equatorial position. The electron domain that has the non-bonding pair must be there located in the equatorial position. And the molecules that exhibit such geometry, such molecular geometry class are your sulfur tetrafluoride and tellurium tetrafluoride. Okay? These are the molecules that exhibit your irregular tetrahedral or seesaw molecular geometry. Any question, class?
None po, sir.
Very good. Very good. Yeah. The other molecular geometries. X3E2, how many electron domains do I have in this molecule class? I mean, in a molecule that has this molecular shape designation. How many?
5 po.
5. 5. This molecular geometry has 2 lone pairs and necessarily the non-bonding pairs, you call them lone pairs, the 2 non-bonding pairs must be located at the egg-shell position. So you get a T shape. A T shape. Or it could be 2 in the equatorial position. Okay, more particularly, 2 electron domains that contain your lone pair must be at the equatorial position. There could also be 2 in the egg-shell position. You get a T-shaped molecule. Example of this molecules, example of the molecules that exhibit such T-shaped molecular geometry class are your chlorine trifluoride and your bromine trifluoride. Okay? The 2 electron domains that contain lone pairs class must be coming from either the 2 egg-shell positions or 2 equatorial positions. Okay? Now the next one class is your molecular shape designation that has AX2E3. How many electron domains do we have in this class? X2E3.
5 po.
5 electron domains. It's linear, meaning the two electron domains that contain bond pairs class must be the 2 electron domains in your axial positions, and the three electron domains that contain your non-bonding pair must be there at your equatorial positions. You must remember that. Must be there at the equatorial position. So you get a linear shape of your molecular geometry. Molecules that exhibit such linear molecular geometry are your xenon difluoride and your iodine dichloride. Okay? Then, this one class, how many electron domains do I have?
6 po.
6 po.
Electron domains. 6 electron domains. And I get, from the 6 electron domains, I have one electron domain that contains non-bonding pairs. There are 5 which contain bonding pairs. Now, of course, it is necessary the one that has non-bonding pair class must be one of the 2 axial positions electron domains. One of the two axial position electron domains must be containing a lone pair or non-bonding pairs. And of course, the other 5 should be there in your equatorial positions. The other 5 would be the equatorial positions, which are, of course, these are containing bonding pairs. You get your square pyramidal. And 5 electron domains contain bonding pairs, 4 in your equatorial positions and 1 in your axial position. The 4 in your equatorial position and 1 in your axial position would be the electron domains that contain your 5 bonding pairs. So you get a square pyramidal geometry. Molecules that exhibit such a molecular geometry class are these 2 molecules. What about here? X for E2. How many electron domains?
6 po.
6. Okay. 6 and 2 electron domains must contain your non-bonding pairs, and 4 are bonding pairs. Of course, necessarily be the 2 electron domains that contain your non-bonding pair must be those 2 electron domains located in the axial positions. Kaya square planar yung shape ng molecule. And of course, the 4 electron domains that contain bonding pairs class are those 4 electron domains in your equatorial position. Okay? These are the molecules that exhibit such molecular geometry. Your xenon tetrafluoride and your bromine tetrafluoride. Okay? Any question, class? Yes, any question do you have? Any question?
Sir, I do have question po.
Yes.
Does this type of geometry po ba is applicable to all expanded octet lang po?
Molecular geometry, not necessarily the expanded octet. Not necessarily expanded octet.
Noted po, sir. But this yung nasa presentation po ngayon.
Mostly, but not only for expanded octet.
Noted po, sir. Thank you
Kaya
po.
molecular geometry, hindi naman expanded octet ang water. Okay?
Noted po, sir. Thank you po.
Okay. Sino, Mr. ano na to?
Moya po.
Okay, Mr. Mo. Not necessarily be, but most of them are, of course, those that exhibit expanded octet. Any question pa, class?
None po.
Okay. Sa laboratory, anong hydrocarbon derivative ang natapos nating nomenclature?
Sir, if I'm not mistaken po, yung sa alkyl halides po.
Alkylamine sa alkyl halide? Hindi pa tayo nag-aldehydes?
Not yet pa po.
Okay. Aldehydes, alcohols, hindi ba?
Hindi pa din po, sir.
Okay, alcohols, aldehydes, ito. So, gawin natin yung mamaya. Tomorrow class, quiz natin sa Lewis structure at saka molecular geometry. Quiz natin sa Lewis structure and electron domain and molecular geometries. Ha? Are you sure? Di ba tayo nag-aldehydes and ketones?
Yes po, sir.